Welcome back to the lab, folks. Today we're going to start a new experimental project sponsored by our friends over at PCBWay. And what I want to do here, as you can see here, we have a picture of a Class B amplifier. And just the other day, I was having a discussion with somebody, and he asked me about what I like to do, what my hobbies were, and I said, well, my hobby is electronics, and I like to do that very much. And he said, well, what kind of electronics? And I told him that I, build things, I design things, I play around, I experiment. He says, oh, well, like, could you build a guitar amplifier or something like that? And I said, well, sure, I could build a guitar amplifier, no problem at all. Would you be able to make it cheap? And I said, well, that's important if you want to put it into production, but I think I could. And immediately came to my mind at that point in time was using a Class AB amplifier. But then I was thinking more and more about it. I said, well, Class B amplifiers, they've got a lot of desirable features. They're very low power consumption when they're not doing anything. Very simple. As you can see, there's just basically two active components in a Class B amplifier. In this particular case, it's a TIP142 and a TIP147, which have got a lot of gain, and they're reasonably powerful. And the drive current would not have to be that high. So that's why I chose this. But, there's some difficulties there, right? We have the problem of crossover distortion. What that is that, this is an emitter follower. So whatever voltage you have coming in here, you got slightly less than it. So your gain is a little bit less than one coming out, because you have to drive these double transistors in this case here. And to get anything out of them, you need to be above the VBE. And the VBE here is twice normal. So it's about 1.5 volts for each of them. You have that dead zone as the voltage here goes up and down. It comes up to minus 1.5 volts. This transistor will turn off. And then as it goes through zero, it has to go up above 1.5 volts before this transistor starts conducting. That dead zone is this flat spot here in your output signal. And in the case of using Darlingtons like we're doing here, that's significant. That's going to be a huge amount of crossover distortion. And we have to somehow overcome that. So I was thinking, why not do something along the lines of this? Stick an operational amplifier in there. The nice thing about this is we can set the gain to something closer to the normal gain that you would have for an operational amplifier. You just give it a huge, big, beefy output stage so they can drive a lot. Another nice thing about the operational amplifier is that it can slew across that 3-volt gap that we have very quickly and reduce that crossover distortion to an absolute minimum, possibly maybe even eliminate it. So this is my first stage in this experiment. This is what I want to do. I want to try this out. I've never actually done this before. I've read about it. People don't seem to actually implement it. They always implement some little modification to it. But I want to try this out the way it is. And that's going to be the heart of this project. And before we go much further, let's get a short word from our sponsors at PCBWay. One of the really cool things about working with PCBWay is their complete clarity into the process that they have. So here's a board that I ordered, and I can go in and I can look at the production tracking on it. You can see every single step of the way. So these are all the main steps along the production line here. And if you have any questions about what each of these steps mean, you can go over here. You go to view details, and it'll come up and it'll tell you exactly what each one of these steps is. Provides you information about the step, shows you what the step is like, and you can get further information about the process. It's quite phenomenal, the amount of information they share with you about what's going on with your boards. Once you start using PCBWay, your knowledge about PC boards is going to increase dramatically. It's basically 24 hours after the board is put in, it's then ready for shipping. So at this point now it's ready for delivery, and the next thing that will happen is the shipping department will send it off to me. Let's get back to our little project. So let's have a look at this circuit a little bit more detail. We do have a nice high input impedance, basically whatever this resistance is here. So I'm going to go for a 100K audio taper potentiometer here. We're going to have a 1 UF capacitor coming in. That'll give us a very good frequency response down the low end. We're also going to use a TL081 because it does have the ability to set the offset. So what I want to do is be able to set the offset such that when you turn the power on and there's no signal going into it, I want to be 0 volts here. I don't want this to pump the speaker. So he's going to put an 8 ohm speaker out here, and that'll be our output. And then we'll set the gain. I don't know what I'm going to set it at, but the gain will basically R1 plus R2 over R2. And that's how we're going to set it up. This is the circuit we're going to implement on the PC board. Now, what I've done here, it's not a lot. I've put in potentially a bunch of diodes here. Let's say this circuit doesn't work out and the crossover distortion is still horrible. What I could do in this version here, if I build the board up this way, I can start sticking in diodes here to kind of reduce that gap, that 3-volt gap. So for every diode I put in here, I reduce that gap by 0.5 volt. And let's say I put in all 4 of them, and let's say they reduce it more than the sum of the 2 VBEs of these transistors. That's why these resistors are here. I could put a small resistance in there that gives some negative feedback to the transistor if it starts to conduct a little bit. And then these resistors here are just to maintain forward biasing of these diodes here. But the way I'm going to wire it up initially will be like this to see if that works. And then the experimental part of it will see what we have to do as far as putting in diodes here and stuff like that. Well, in order to pass grade as a simple guitar amplifier, which is, by the way, not very high standard. Most of the little cheap guitar amplifiers I've had a look at have got crazy distortion. So I can't imagine we're going to need to do much. But at least we have the capability there of potentially producing something way better than your average $100 guitar amplifier. Okay, so that's the experiment, and we may take this further. Depends on how it goes. It's up to you guys. If you guys get interested in it, you view it a lot, I can take the next step and we can put in some tone controls. We may even build one up into an actual cabinet and see what it's like. The sky's the limit. But let's have a look at the layout here. So these are potentially those emitter resistors that we might have to put in. I've left a lot of room for them. I doubt I'm going to need them, but they're there just in case we have to do the experiment. And what I'll do, get that circuit that I want to start out with, I just have to jump over to here and jump over to here. And then these here are the other little diodes, right? So we just have to jump from here to here. And then that's the circuit that we want to start the experiment with. And as usual, I'll try to keep most of the traces on one side so that I can have a nice unbroken plane as much as possible on the back in order to make the ground a very low impedance. It's always a good practice if you're going to do PCB design. These are 2 resistors here that set the gain. I haven't put any value of them yet because I haven't decided what I want to do with that yet. Here's the potentiometer to adjust the offset, and that's it. So I'm going to get these Gerber files made up, sent off to PCBWay for manufacture. And as usual, when the board comes in, we'll build one up and we'll begin our little experimental project here. All right, folks, that's all I had for you today. I hope you could join me along the way on this project. It should be a lot of fun. Bye-bye.